Good morning. Today we're going to be discussing normal distribution curves and z-scores, and then we're going to look at Excel and learn how to do measures of central tendency in Excel rather than doing them by hand because it can become very tedious when the sample size becomes much greater. So first we're going to look at measures of central tendency because I feel that if you can't grasp these concepts here, it's going to be difficult to grasp the concepts we talk about later in the video. So first we're going to discuss the mean. You have your sum of your scores that are given in a problem divided by the number of scores you have, or your average. Then you have the median, the number in the middle when you order them from least to greatest or greatest to least, however you want to do it, and then that gives you your middle number. If there's two, so if it was 13 and 17, you would have to take the average of 13 and 17 using this formula up here. You have your mode, the number that occurs the most often in a set of data. So here it would be 9 because 9 occurs 3 times and all of the rest of them occur less than 3 times. Then you have your standard deviation. This constitutes as your average deviation, the average number that each particular score deviates or differs from the mean. So here's your formula here. We'll go over it here in just a second. But I wanted to point out that you have to do n-1 to account for error because you can't just use n from up here. You have to subtract 1 because of the error that's in the calculation itself. So how, why, and when is this used? It's used in social sciences, deals with human behavior, so you may be talking and say, well, was my SAT score significantly higher than the average? That's what you could use this for. To determine if one score is significantly different than normal trends. So was yesterday significantly warmer than the average? Looking at a sample as a whole, but focusing on a score compared to the mean. So rather than two means, you're going to look at a score because two means would constitute a t-test. What is a normal distribution curve? One of the most important concepts in statistics. It holds 100% of normally distributed data. It's a bell curve also because of its shape. It assumes the data is normally distributed. So in a problem, it may say, assuming the data is normally distributed, find the z-scores of the following scores of x. So 68% of the data is within one standard deviation on each side of the mean or 2 standard deviations total here. Then you have 96% of the data is right here, and that would be 2 standard deviations on each side of the mean or a total of 4. Then you have 100% of the data here because this is really 2.5% right here, but that's a little bit complicated. But it's 100% of the data within 3 standard deviations on each side of the mean or 6 total standard deviations. What is a z-score? A z-score represents the number of standard deviations a particular score is from the determined mean. So you have your mean here, your score here. Your score minus your mean divided by your standard deviation gives you your z-score. Here is half of a normal distribution curve. I'll show you a full one like we just saw in the previous slide here in a second again. But you have 0, 1, 2, and 3, and then again, -1, -2, -3 on this side. These are your z-scores right here. This constitutes your significant difference. Some people say 1.96 to be more accurate, but most people can just say 2 just to simplify it. Here's another example. You have your scores here. Your mean score goes here at 0. These are your number of deviations from the mean score on either side. Your percentages here. Your significance level, that 1.96, or some people say 2. And this can only be used when your data is assumed to be normally distributed. So here's an example problem. 10 students take a test and earn the following scores. So you have these scores here that they give you. We're going to focus on question A first. What is the mean and standard deviation of the test scores? So here you're going to do your mean. You have these test scores here. You're going to add them all up, divide by the number there are, 10. You can count, or it says right there, 10. So it's going to be 809 divided by 10 is 80.9. Then you're going to have your standard deviation. Here's that complex formula. This basically says you can take it step by step. X minus m. Okay, so you're going to take x minus m, whatever that is. You're going to square that. That's going to give you this number right here. I just didn't do the x minus m and write it all out because it would be really long. So I just did x minus m. So 74 minus 80.9 squared is going to give you that. Then you're going to do 86 minus 80.9 squared. is going to give you 26.01. 92 minus 80.9 gives you 123.21, so on and so forth. Then you're going to take the sum of all of those. Once you find all of them for all 10 scores, the sum, which came out to 1,178.9. Then we're going to divide it by 9 rather than 10 because of that degrees of freedom and that error that we're calculating in. So you have 9, okay? Then you're going to take the square root of that, gives you 11.44. Your mean, your standard deviation, question A answered. And then you're going to look at B. If a student took the test and earned a 96, what would their z-score be, and would it be significantly different? So here's your normal distribution curve, okay? You have your mean. To get these numbers here, all you're going to do is you're going to take your mean plus your standard deviation, gives you that. This number plus your standard deviation gives you that. This number plus your standard deviation gives you that. Here, this number minus your standard deviation gives you 69.46. Then you take 69.46, subtract it from your standard deviation, gives you 58.02. Here's your significance levels of 2, 1.96 if you want to go on just the little side of the line. Okay, so here's your data given. They gave you the score, 96. You found the mean and standard deviation, filled out this. You can use this to kind of get an idea of what your z-score is going to be. So if you estimate 96, it's somewhere in between here, a little bit on this side. So you're going to say maybe 1.3, 1.4. It's not quite in the middle, but it's almost there. So then when you use your z-score formula, because they asked for the exact score in the problem, you're going to go z equals x minus m over your standard deviation. X minus m over your standard deviation gives you 1.32. Here's how it would be written. Z equals 1.32, and it's not significant because the z-score is less than 2. But it's not down here in this category either. So it's right here, so it's not significant. Here's how it would be written. This has to do with confidence interval levels, something that we're not really going to go over, and probabilities. So we're really not going to go over that in this video. Now I'm going to show you how you can use Excel to do your descriptive statistics or your measures of central tendency so that you don't have to do them by hand when you get a large sample size. So first, you have your Excel sheet. You're going to go File, Options. It's going to open up to this. You're going to click on Options. Then it's going to pop up as this here. You're going to click on Add-ins, right here on the Excel options, Add-ins. And then it's going to come up with this. Mine is active because I've been using it. Your guys's, if you haven't used it, will probably be in the inactive box. So you're just going to click on that. Make sure it's not the VBA one. You just want the analysis tool pack. Then rather than click OK, you're going to click Go right down here. And it's going to pop up with this box. And you're going to click Analysis Tool Pack. Make sure that little box is checked. Then you can press OK. Then you were over here in File. You're going to go to the Data tab. And you're going to make sure this little data analysis option is available. Okay, so now here's a number of scores. This could be anything. It doesn't really matter the context. I didn't make a context for it. I just made up some scores so we could practice. Okay, so here's your scores for, we could just say, a test. Okay, so these scores, I'm going to show you how to use the data analysis to get your descriptive statistics. So you're going to click on Data. Then you're going to go to Data Analysis over here. You're going to click on that. And it's going to pop up this box right here. You're going to make sure this descriptive statistics is highlighted, and then you're going to press OK. Okay, you still have your scores, nothing's changed. It's going to pop up this box here. So you're on Data, Data Analysis, Descriptive Statistics. You have this input range. Okay, here you're going to highlight your label all the way down to the last score, not including that last blank box. Then you're going to have this dotted line around the edge. If you let go right here so that that's all highlighted, that should be in this box right here in your input range. You're going to click Labels in the first row to tell Excel that you have a label here. If you didn't include this, you would uncheck that box. Then you're going to click Summary Statistics, and then you're going to click OK, and it's going to pop up this in a new tab down here, so you'll have your original data, and then this, it'll probably be Sheet 1 and Sheet 2. I just renamed them to keep them in order. So you have your labels here, mean, median, mode, standard deviation, and your count, how many there were. So 20, with a mean of 1,081.95, your median of 1147.5. There was no mode because they all occurred once, and then your standard deviation of 169.72. So now you have this here, you have your scores and your z-scores. Okay, so I'm going to create this little table just to help me keep all of this together. So you have your mean and your standard deviation I put over here just for reference, and then your scores. So to get your z-score, I'm going to show you how to do it so you can do it all in one. Okay, so you're going to have this here. So you're going to type equals in this first box. B3, you're just going to click on this cell. Minus, you're going to type in your mean right here because you're using this formula. Close your parentheses on either side. Divide it by your standard deviation right here. And then you're going to click enter, and it's going to tabulate your z-score. Then to get them to go all the way down right here on this line, if you put your cursor right here on the corner, it'll make a little black plus, and then you're just going to drag it down and it'll populate this. Okay, so now you have your mean and standard deviation still and all your z-scores. Now we're going to look at the significance level. Okay, so you're going to look, are any of these greater than 1.96 or less than negative 1.96? You're going to look, none of these were. So all of this is going to be no. Now an option where you could, maybe if the z-score was 1569, your z-score when you calculated it was 2.86. So yes, it would be significant, but we're not going to discuss that because it was not part of our original data. So now you're going to look at the probability of getting this score. Okay, so you have this score here. What is the probability of getting it? So what you're going to do is you're going to look at this z-score and you're going to look at these critical value tables. You can find these online. This one that I have, I drew a bigger representation of this down here, gives you the probability of this right here, rather than just this little section. Some of them give this little section. This one gives the whole thing. So you're just going to look over. So 0.96, you're going to look, your first decimal is here, sometimes with a number in front. So 0.6, 7, and you're going to find where they meet right here. Oh, sorry about that. That was the second one. The first one is 0.96, and that one's right here. So it doesn't matter which order you go in. You just find the first one, so 0.9, and then 6 is right here, 0.8315 or 83.15%. Okay? It's different for the negatives, however. So this one is negative 0.67. So this is giving you just this little bit, not even including any of this part passing the mean. Okay, so you have negative 0.67, so negative 0.6, 7.2514 or 25.14%. Okay, so you just look for your first number, your second decimal, find where they meet, that's your probability. And that's what it would look like all filled out. Now we're going to talk about the probability of getting this score compared to the mean, or this little percentage right here. So if you're looking at this, that what we just calculated, if your z-score is over here, it's going to give you this whole probability right here. But if you just want this little probability right here, that's where you're going to have to do a little bit more math. So you have this here. So you have 0.8315, then you're going to subtract it from 0.5. Because if you look at this constitutes 50% of the data, and you want just this little bit right here. So you can take whatever you found your z-score to be, minus 0.5, and that'll give you that percentage right there. So in this case, you'd have 0.8315 minus 0.50, then if you press enter, 0.3315. Okay, you do the same thing for this one. 0.7486 minus 0.5, press enter, and it gives you 0.2486. Now, it's a little bit different for the negatives on this as well, because when you look at this, it was giving you this little bit, but you want this little bit right here. So you know that this constitutes 50% of the data, so you're going to take 0.5 minus the bit that you have is going to give you that missing piece that you want. Okay, so if it's negative, you take 0.5 minus the probability of getting that score right here, and then you press enter. Oops. and that's going to give you this right here, 0.2486. It might be a little bit difficult to see on the screen, but if you guys have questions, you can just comment and then I can further explain too if you guys need help. So you have this here. So this one would be the same thing, 0.8707 minus 0.5, because that's positive. So down here the rule, if P is greater than 0.5, you're going to subtract this P right here minus 0.5. And if it's less, like these negative numbers, then you're going to take 0.5 minus that number that's there. Okay? So here's what it looks all filled out. Okay, and then I'm going to show you how to plot it on a curve using your data analysis tool pack, which we found. So I'm going to use the same problem. So you have this data analysis tool pack right here. Okay, and you have all of this here. So you have your mean. You're going to add, you found it here. You're going to add and subtract your standard deviation on each side to get your z-scores. And then I just plotted the first one. You can plot all of them and get a general idea of where your z-score is. It makes it so much easier than plugging them all into the formula. So you have this one, you can estimate it's about 0.95. It's almost to 1, but not quite. And the actual answer was 0.960744. So it's really close, and you can use this to get an idea of where you're at and if you're getting the right answer when plugging them into the formula. So if you guys have any questions, just leave them in the comments and I'll try to get back to them to the best of my ability. And thanks for watching.